Alright, we're going to do some examples of resonance in Lewis stat structures. Alright, so with resonance, what that means is we have one or more valid Lewis stat structures. Typically that happens if you have double or triple bonds in your molecule. So really what happens is your double or triple bond, they can actually shift between two atoms. Alright, and so by shifting, they're called resonating. These double bonds are resonating or moving between two different atoms. And that's why I say it's the average of the resonance structures. Okay? So, for example here, NO3, the nitrate ion. So if you look at nitrogen, all right, there's your 5 electrons there. Oxygen has 6. 1, 2, 3, 4, 5, 6. Okay, well that oxygen, we're going to make a double bond there. Other oxygen we'll put on top of here. 1, 2, 3, 4, 5, 6, and that's bonding with that. Our third oxygen we'll put over here. 2, 3, 4, 5, 6. All right, then remember you got that -1, so we'll put that electron there. All right, so we're going to rewrite this a little cleaner down here. N, O, O, and O. All right. All right. So as you can see, here's your double bond over here. Now I could probably work over here as well, or up here. All right. So, and yeah, really what happens in the atom itself, this double bond will actually bump over and become an unshared pair of electrons. And when that happens, an unshared pair of electrons from another atom will kick down and turn into a double bond. So what you have here is, there's your nitrogen, there's your oxygen on the left, looking normal. Now the one on the right lost its double bond, looks like that, and the oxygen on top gave up one of its pairs of electrons, become a double bond. And then there you go. And you see they look pretty much the exact same thing, but just double bond move from one to another. And same thing can happen where that'll pop back up, and that shared pair of electron or unshared pair will turn to a shared pair. And you got something like this. This is back to a single bond. All right. And then that bond can become back to a single pair or unshared pair of electrons. These unshared can turn back into a double bond and zips right back over and looks just like that. All right. Now, in real life, that happens all the time, which means in the nitrate atom, this double bond's here, and then moves here, and then moves here, and back there, and just constantly moving over and over and over again. It's just always shifting. So it's never really in one spot. All right, and that's, we talk about Heisenberg's uncertainty principle, where you don't know exactly where electrons are. So that kind of satisfies that rule there. Another good example here we have is benzene, C6H6. And now benzene is cyclohexane. Or it is a cyclohexane. 1, 2, 3, 4, 5, 6. All right, so there's your 6 carbons in a circle. And we have 6 H's attached to each one. So as you see here, carbon is supposed to have, a total of 4 bonds. Only has 3. So everything else is filled with double bonds. So we'll put one there. We'll put one there. And we'll put one there. Perfect. Now these double bonds will shift. That will pop over there. That'll move over to here. That'll move over to there. So we have here is, we can rewrite it. Put our hydrogens back there. All right. And so now that double bond's there, that one's there, and that one's there. All right. So that's your resonance. And that's always happening. So these electrons, these bonds are shifting here as these electrons are moving. And then these electrons again will kick over here, that'll move over there, that'll move over there. So they're constantly moving in a circle. So really what you have here is if you rewrite it, this is the shorthand. And we have carbon, right, and your hydrogens. And what we'll do is we'll just put a circle there. That circle just means that the electrons, those double bonds, are constantly moving around. Okay? And even more shorthand, this is what I did in organic chemistry. What is that? This is a shorthand symbol for benzene. Right there. So that's how resonance works. So the way to work out resonance, or to see if you have resonance, is when you do your structure, if you see kind of like this, you say, okay, I got my double bond here. Oh, I could work out if it's over here, but also I could work out over there. All right, so if you see that, then that means you can draw it again, and you have a resonance structure. But it only works with double and triple bonds. You know, obviously, you have single bonds, you really can't tweak them that much to make it look resonance. All right, so see again, see double or triple bonds, if you can move them and they still satisfy all the rules for Lewis stat structures, then yeah, you have yourself a resonance structure.